Hi students, it's Ms. Gomez. Today we are going to learn about logarithmic function graphs. I was going to do this on my webcam, but I couldn't get it to where you could see really well, and so I tried it on my whiteboard and there was a glare, so I'm going to try and just edit this document live. If there is an issue, just bear with me while I try and fix it because I have not done this before. Okay. So logarithmic function graphs, you should know that logarithms are inverses of exponentials, okay? So they're inverses of each other. So the number one, this graph, this is going to be review from the week before we left. I know that was a long time ago. You may not remember, so we're going to go through this, but this we have already done. We're going to use this to be able to find this. Because just looking at log base 2 of x, we don't really know what to do with that. Like, what do? Okay, so we're going to use the fact that these two are inverses of each other to find this. So first, we need to find number one. So, step one, okay, we're going to plug in the x values into the equation. I don't like the word that there. Okay, so we're plugging these values right here into this x right there. Okay, so what this is saying is 2 to the negative first power. Okay, well 2 to the negative first. Negative exponents flip them, okay? So that means it becomes a fraction. So 2 to the negative first is really just 1/2. Okay, here we are going to have 2 to the 0 power, okay? And this is where you would all yell, what's anything to the 0 power? 1. That's right. So smart. Okay. 2 to the first power. Well, that's just itself. That's 2. 2 squared. That's 4. And 2 cubed. Now remember that's 2 times 2 times 2. So that's 8. Okay. Once you have these coordinates, then you're going to do step 2, which is plot them. Okay, plot these points. So we're going to take over negative 1 up 1/2. So note 1/2. Oh wait, over negative 1 up 1/2. Okay. Nope, that's still not there. Oops. Bear with me, kids. Close enough. Alright. Over 0 up 1. So over 0 up 1. Over 1 up 2. Okay, there you go. And then over 2 up 1, 2, 3, 4. Okay. And over 3 up 1, 2, 3, 4, 5, 6, 7, 8. Yay! Okay. So now once you have drawn your points onto your graph, you are going to connect them the best you can, and that's going to be the best I can do right now. Okay, so remember that both sides have an arrow, so this has an arrow and this has an arrow because they go on forever in both directions. Okay, now something I saw before the break is a lot of you didn't stop your arrow, like you didn't curve it this way. You would let it extend down here. You don't want to do that because we have our asymptote right here. And that asymptote means that we cannot move it, or we can't go past it, okay? So this asymptote is that this is like saying plus 0 in our equation. It means we cannot go below 0. It approaches 0, it gets really small, close to 0, but it never reaches 0. So the equation for our asymptote is y equals 0, okay? Oops. Okay, right here. So the asymptote is, it wants to know if this is horizontal, which means side to side, or vertical, which is up and down. So this is horizontal. Okay. The equation we already said is y equals 0. Our domain and range. So it wants to know if where it goes. So domain is our x's, so that's left to right. So it goes forever and ever and ever this way to negative infinity, and forever and ever this way to positive infinity. So you can put negative, and I'm going to have to insert a symbol, infinity, to positive infinity. And it never reaches them, so we use parentheses, not brackets. Okay. Or you could say x is an element. I don't see our little E button that we normally use, so maybe I will just use that. And then where's our R? Okay. Well, oops, we could use that R. That R looks nice. For this argument's sake, let's just use this capital R. Okay. This is x is the element of all real numbers. So you could say negative infinity, positive infinity, or all real numbers. Either one I'm okay with. Our range is our y values. Okay, so that's from bottom to top. Okay, so this goes down to 0. It does not cross 0. It does not equal 0, but it gets really close to 0. So we're going to start off with 0 as our lowest point. And we're going to go up forever and ever and ever and ever to infinity. So we're going to need another infinity. Alrighty. We can never reach infinity, so that's open. We are not reaching 0. It's not part of 0. So we also get a parenthesis here. Okay, it gets really close to it, but it's not there. So this is our function. Okay, remember these are not included points. Now that we have this, we need to go over here to this. So remember, guys, these are inverses. Okay, if we did the loop-de, oh no, if we did the L, sorry, we did the L where it goes boom, 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 right? You would get this, okay? So, step 1, of inverses, right, is we switch x and y, okay? So what that means is our xy coordinate becomes yx. Oops. Okay, so we're going to take our y values, and they're now going to be our new x values. Okay, so 1/2 is going to be right here now. 1/2. Yeah, that's small. Okay. 1, 2, 4, 8. Okay, all I did is I took these values, nope, not all of them. I took these y values and I put them here as our x values. Okay, same thing. I'm going to take our x values and I'm going to make them become y values. So -1, 0, 1, 2, 3. Okay, now we're going to plot these points. Over 1/2, down -1. Yeah, that's close enough. Okay. Over 1, up 0. Over 2, up 1. Over 1, 2, 3, 4. Over 4, up 2. And over 5, 6, 7, 8, up 3. 1, 2, 3. Okay. So you should plot your points. Oh, forgot to write that there. Step 2. Plot points. Okay, once you've plotted your points, you're going to need to connect them the best you can. This is going to be the best of my ability right now. Okay, same thing with this one over here. It does not go past this 0. So just like we switch x and y, we're also switching our asymptote. So now, our asymptote is going to be right there on the y-axis. And since this is a vertical line, meaning it's going up and down, our equation is going to be x equals 0. Okay? This happens because for any y value, up 1, up 0, up 2, up 5, it's over x equals 0. Okay? And that's why horizontal lines are y equals 0, because for any x value given, it is up 0. Okay? So right here wants us to tell if it's horizontal or vertical. Well, this is going up and down, so it's vertical. Okay. We already stated that our equation is x equals 0. Okay. Our domain, so that's our x values from left to right. So the farthest left point is it gets close to 0. It approaches 0. It never reaches or crosses 0. Your graph should not go over here in this left coordinate grid. Okay, so we start at 0 and we go forever and ever and ever this way to infinity. So we need to put in our infinity symbol. Where is it? Where is it? It was here earlier, wasn't it? And replace TM with, oh no, there it is at the top. Okay. Infinity is not included. And in this case, 0 is not included either. Okay. So you should not have a bracket. This should be a parentheses. Our range is our y values. So up and down. So this goes down forever and ever and ever. And this goes up forever and ever and ever. So this is going to be from negative infinity to positive infinity. Hi, so my other video cut off. It cut me off at 15 minutes. So if there's like a weird buffer, that's what it was. As we said, the range was from negative infinity to infinity, or you could syntax that as y is the element of all real numbers. You guys feel free to have paused this video, rewinded, slowed it down, went back. If you have questions regarding this, please leave comments on the Google Classroom or shoot me an email and I will respond. There is one thing I wanted to mention that I couldn't do because I wasn't Word Editor. It just would have been complicated. On the hard copy notes, there is this little portion that shows that you can reflect, since these graphs are inverses, over the line of reflection. So y equals x is over the line of reflection. You'll see that little green graph. That is our blue graph, the first graph we did, y equals 2 to the x. Gosh, this is hard to... And the purple graph is the log base 2 of x. So you see how they're just flipped over that line? That's all we did. When we switched x and y and we switched the domain and range and we flipped the asymptotes, that's all we did, is we reflected it over that line of y equals x. So I just wanted to mention that to you guys. There is an assignment with two similar functions to this. I think it's y equals 3 to the power of x, and then there is y equals e to the x. Now remember, e is a number. It is 2.71814 something, and I think, don't quote me. And ln of x is log base e of x. So keep that in mind when you are doing the assignment. Please have that assignment turned back into the Google Classroom by next Monday. Okay, that is the due date, next Monday. I will upload the calendar and the assignment, but please have that done and turned back in. There will be another video this week of parameter changes of log graph functions, and that will also be due Monday. Those are the only two assignments that you'll have this week. So like I said, let me know if you guys have questions, and I miss y'all. Okay, bye-bye.